record these things that we're doing on finance. And then I can post these, after class in Canvas. It takes a while for these things to process, though. So what we're doing is we're going to go to finance. So we'll be talking about loans and mortgages and stuff like that over the next several weeks. And you all will be doing a project. We're not ready to start that yet because you got to learn about mortgages. So it's kind of a helpful project that we do on buying a house and how mortgages work. So I think that's really good knowledge for everybody to gain. To begin with, what I want to kind of go through today is just look at simple and compound interest and kind of show you how all that stuff works then. So basically on this first example, it says you take a stereo to a pawn shop. They offer to give you $200 cash for it. If you want to get it out of pawn, they will charge you 12% interest after 30 days. So how much will you have to pay to get your stereo back? And a pawn shop uses simple interest. It's one of the few things out there that uses simple interest. Most places will do some sort of a compounding system, which we'll talk about today. So really what you have to do is you have to find 12% of 200. We've learned how to do that. Remember, if you have 12%, what do you do to the decimal? You move it back 2, right? Because 12% means 12 over 100. And if you take any number and if you divide any number by 100, that's what happens to the decimal. So that's the reason that we do that when we do a percent. So that would change to 0.12. So what you want to do is just go ahead and write on your notes that you're going to do 0.12 times 200. And then you could do that on your calculator, and that will give you $24 worth of interest. Okay. So now, when you go to the pawn shop, what you have to do is you have to give back the 200 and you have to pay them interest. That's how they make their money. So what you would do is you would have to pay back the $200 plus the $24. So in order to get your stereo back, you would pay $224 after 30 days. And typically, pawn shops and stuff like that, they might have a 60-day term or a 90-day term on that. So they would just charge, you would just get charged $24 interest each month on that. That's how that works. So that's what we call simple interest. And what we're going to look at is simple interest has a certain formula to it that we're going to talk about today. Compound interest, we're going to talk about what happens when you do interest annually, when you do it like every month, and even when you do it continuously. So we're going to talk about all those basic situations then. A couple of basic definitions on here is the principal. That just means the balance upon which interest is paid. So on the example I did, the $200 would be the principal. Simple interest is paid only on the original principal, and it's not on any interest added at later dates. Compound interest, when we learned about that today, you actually figure interest on interest. So basically, the interest changes on some regular basis. So we'll talk about that. When you do compound interest, the interest is paid both on the principal and on the interest that's already been added to the principal. Okay, so we're going to talk mostly today about simple and compound interest and kind of get that idea established. Okay, all right, so let's go to this second page and we're going to fill out a table, and this will kind of show how basically how simple interest works. Okay, so with this one, this says Nancy is investing $200. That is going to be your principal. That's the amount that we're going to be figuring interest on. Okay, and it says that you earn simple interest at an annual rate of 2.5% per year. Okay, and this is going to be simple interest. So the way we do that is just you do interest on the 200 over and over again. Again, when you do 2.5% of a number, you move the decimal to the left. Sorry about that. Sometimes I forget to turn my phone off in the morning. Okay, sorry about that. Okay, so we move the decimal back 2, so you'd have 0.025. Okay, or remember, a percent just means to divide by 100, and I like to keep mentioning that because A lot of times students move the decimal back wrong. I mean, you can always just divide by 100 and it's going to move the decimal back for you right anyway. Okay, now I think I did that wrong. I typed it in my calculator wrong. So it's 2.5 divided by 100. Older calculators used to have a percent key on it, and all it did was take the number and divide it by 100 anyway. Okay, so it moved the decimal for you automatically. So don't mess up when you move the decimal over. Okay, so anyway, here's what we want to write down. First of all, we're going to start with $200, and this is like at the very beginning. At the very beginning, there is no interest that is being charged. So you're going to have a total of $200. Okay, like that. Now, what we're going to do is just at the end of a year, we're going to figure out the principal. And this principal is always going to stay the same on this. So now what we're going to do at the end of a year, we're going to go ahead and we're going to do 0.025 times 200. And when you do that on a calculator, you're going to get $5. Okay, so that means that you now are going to have 200 plus 5. So now the total interest that's being earned on this, and this is an investment, you're earning interest, you're at $205 like that. So that's after a year. And this is savings accounts don't work with simple interest. They tend to work with compound interest, either daily or monthly is more typical, okay? So now, when we go to the next thing, we still have a principal of 200. That principal is not changing. It will change when we look at compound interest, though. So what we do now here is we do the same thing again. We just do 2.025 times 200. We get $5. Okay, so now you've got basically 205 plus 5, so you've got $210. Now, we don't have to keep doing that same calculation over and over again. What I'm trying to show you is you're just going to keep getting $5 interest over and over again, okay? So if you go to the next level, that principal is going to remain the same. You're still going to have $5 of interest. Now, how much money do you have? 210 goes up to what? 215, good, okay? And see, now you can do this all in your head. This is still going to be 200, 200, 200. The interest is always going to be $5. And this thing you can see is going up by $5. So you would have $220, then you would have $225, then you'd have $230 like that. Now, we haven't learned the simple interest formula yet, but the formulas I'm going to show you in a minute would be able to allow us to figure out that 230 with just one simple calculation anyway. Okay, and that's what I'm going to show you. So that's the idea with simple interest. The principal remains the same. The interest will always be the same, and you're just going to go up a certain increment at the end of every time period. Okay, does that make sense to everybody? Okay. Simple interest is simple, okay? It works this way, okay? Any questions on that? Okay, all right. So now I want to just introduce you to these two formulas. And these are things that probably you've seen at some point in time in your schooling, okay? I don't know when you learn this, middle school, high school, it all depends on what kind of classes you're taking. So we have I equals PRT. You're just doing the principal times the rate times the time. And I is the interest, P is the principal, R is the interest rate, T is the time in years. So let me use the example I just did, and we'll go down and we're going to do these two formulas on example 3 at the bottom, okay? The other thing is, if you want to find the amount after a particular point in time, you can use the formula principal plus the interest. And what's going on this formula is just saying P is the principal and PRT is the interest. So kind of like on the problem we just did the principal and added on the interest. Okay, this formula can be written this way. This is the same formula, it's just written in a little bit different way, and you can use either formula to figure this out. So it's really the same formula, it's just algebraically equivalent to that, okay? The only difference with this is A is going to be the amount after interest, okay? So let's go down example 3 and I'll show you how we could do the problem that we just did with these formulas. Okay, so in the example I did, what was the principal on that chart, that table up there? That was what? $200. Okay, so you want to write down that that's $200. What was the interest rate on this thing again? I think that was 2.5%. Now the time is going to be 6. We're going to go ahead and use the 6 years on that like that then. So I'm going to show you how both of these formulas work and how you could get that last row in the table automatically. So it's real simple. When you do the formula I equals P times R times T, what you're going to do is take the principal, you're going to multiply by the rate. What do you again have to do with that 2.5%? You got to do something with the decimal. What do you do with it? Move it to the left too, right? Okay, so that's got to go to the left too, so it's 0.025, and we're going to multiply that by 6. Okay, so if you want to take your calculator, and I'll show you what you're going to get on this, you've got the 200, whoops, I always put one too many zeros in here, times the 0.025, that's your interest, and then times the 6 years, and that's going to give you $30. Okay. Now, what you can do on this is if you want to find the amount that's in your savings account after 6 years, you can do the principal plus the interest. So the principal was $200. The interest is $30. So that means that you would get $230. That's what you get in the last row of that table we filled out. After 6 years, we got $230. So it's automatic that way. So you're using the formula I equals PRT to find the interest, and then you're taking just the interest plus the principal to get the amount in that account. Does that make sense? Okay. Whenever you're tacking on interest in the savings account, you got the principal plus the interest earned when you're doing simple interest. Okay, now I do want to show you how this other formula works. And you could get by in this class without ever using this formula because you can always just do the principal plus the interest. Okay, but let's go ahead and let's get this one plugged in. So replace the P with 200, have your left parentheses, you are multiplying there, then you would have 1 plus the interest rate. The interest is 0.025, and then multiply that by the time, which is 6 years, okay? And you can actually put this in your calculator in one step if you want to, if you're careful about how you use your parentheses keys. You can do this in one step. So I'm going to do that. I'm just going to put 200. You can put the parenthesis. You don't have to put a time sign. Then 1 plus 0.025, and then multiply by 6, like that. And then that will give you the 230 automatically, see? Okay. So that's how you can get, the interest and the amount that's in your account after 6 years at that particular simple interest rate then, okay? Okay, you guys got any questions about how that was calculated? Yeah. Okay, because a percent, when you're doing a percent, what the word percent means, per means divide. That's literally what that means. Cent, like think of a century. A century is 100 years. So the word percent means divide by 100. So if you're doing like 5% of a number, that's the same as 5 over 100, which is 0.05. There's two ways you handle a percent. One way is to move the decimal to the left too. The other way is divide by 100. They're the same thing, okay? And that's literally an easy way to remember that. The word percent really means out of 100, divide by 100. Okay, does that make sense? Okay? Yeah. Yes, and what I did is I moved that to the left. So, I did have to insert that 0 to get 0.025. That's why I mentioned dividing by 100. I see students move the decimal wrong all the time. So dividing by 100 on your calculator that's what that's going to do. It's going to move your decimal for you if you have to. Okay, anybody have a question about that? Okay. All right, so I'm going to have you guys do a problem. Just kind of repeat what I just did, and I'll see if you can kind of compare answers and see if you can do this okay. So it's basically, I'm giving you $1,000. You have a 3% interest rate that's simple interest, and we want to figure out how much is in the account after 20 years. Okay, so let's do that, and I'll give you a little time to work on that, and then we'll start talking about the compound interest. So see what you get. If you didn't get your two handouts, I got these two handouts you do need to pick up today. Okay? You want to make sure everybody's signed the attendance. I didn't call off earlier. Everybody signed the attendance, or you need to do that? Somebody else needs to sign. Got the handouts? Well, we just kind of walk around and see where we're at with that, and identifying everything right, make sure that your percent is decimals moved over, and we'll kind of see what happens. Yeah, that's it. DRT, principal times rate times time, gives you the interest. Once you get the interest, you can add that to the principal to get the amount in the account. Note you got the decimal moved back to the left. Okay. Now that, when I say A means the thousand added to that. Okay. A means the amount that's going to exist after you tack on. Okay. Okay, so that's right. That's you did good. You did okay. I was expecting this to do when I just do that percent one. So, yep, okay. Just do that on the calculator. Just do it. Okay, so how many people got 600 for derivatives? I didn't see too many issues with that. I usually don't see too many problems. I see more problems with the second formula than I do the first formula. But you can actually get by without that second formula. So basically, your principal was $1,000. Your interest rate is 3%, and you have to use 0.03, and then your time is going to be 20 years. So what you would do is you would just take the principal, 1,000 times the rate times the time, and that would give you $600. Okay, so I didn't see too many issues with that. Now, you can do this like this. If you want to get A, you can just do the principal plus the interest. You can bypass that formula every time if that's what you want to do. So the principal is 1,000. You add on the interest, and you're going to get a total of $1,600. That A represents how much is in your account after the interest accumulates. If you do this formula, if you prefer to do this formula, you just do 1,000 times 1 plus 0.03 times the time, which is 20. And if you put that in your calculator, if you use your parenthesis keys, that's going to automatically give you the 1,600. Okay. Did anybody have any trouble calculating that step 3, the A equals P times 1 plus RT? Okay, I just put it in my calculator just like that. Okay, I mean, it'll do the whole thing for you. Okay, all right, so that's simple interest. Does anybody have a question about how simple interest works? Okay, Now, when you start doing problems on this, you have to pay attention to what kind of interest you have, whether it's simple or whether it's compounded. So the next thing I want to talk about is how compound interest works. And we're going to fill out a table similar to what we did on the previous page, but I want to show you kind of how the compound interest works now, okay? Okay, so if we go down example 4, this is the same problem that we did earlier. You've got, basically you have a principal of $200. You'd have an annual compounding rate of 2.5% per year. So again, when you use this as a decimal percent, you want to write that as 0.025. And then we're going to see how the investment performs for 6 years. Now it's totally different on this. So to start off on this chart, you're going to start with $200. You do interest at the end of a year. Annual means every year. So if you have annual compounding, it really means every year, and that interest is done at the end of a year. So at the beginning of time, there is no interest being made. So when you begin, this is just you deposited your $200. So we're going to see what happens after a year. So it's a little bit different on this. We go down to the end of a year, your principal is still 200. And now what we do is we want to do 0.025 multiplied by 200. And you could take your calculator and do that. That'll give you $5. So how much is in your account after 1 year then? 205, right? Okay, you're just doing 200 plus 5. So that would be $205 like that. But it's going to change in the next line here. So it's a little different. So now your principal is $205. If we were doing simple interest, the principal would remain 200 the whole way down, okay? Now what we do is we do 0.025, not times 200, but times the 205, okay? So you have to do that on your calculator. I'm kind of have a lot of these things worked out, so you guys can do your calculator fine. So anyway, we're going to have that. Now, when we get to our amount, what two numbers do I need to add to get to my total now? 205 plus the 513. Okay, good. Okay, so we want to do that. So when you do that, you're going to get $210.13. See, that's how compound interest works, is the interest is going to keep increasing. $5, 513, it's going to keep increasing, okay? Does everybody understand what the difference is here, okay? Okay, is that a yes? Okay, all right. So now we just kind of keep the same system. We go $210.13. That's our new principal. Now we're going to do the 0.025 multiplied by the 210.13. Okay, and I've already worked this out, so this would be $5.25. So see, our interest is going up. Now you're going to add the 210.13. You're going to do the previous total plus the new interest. And when you do that, you're going to end up getting $215.38 like that. Okay, so your amount is growing because your interest is growing. You're going to end up with more than we did when we did simple interest. Okay, now just kind of keep the process. Okay, we're going to bring down the 215.38. Then we're going to do the 0.025 times 215.38. You work that out on your calculator. That's going to give $5.38. Okay, now I'm just going to kind of write what the running total is here. Now you're going to have $220.76, like that. And then we'll just do a couple of more calculations. So now your new principal is 220.76. Then you're going to do the 0.025 times that 220.76. That's going to end up giving $5.52. Okay. Then your new principal will be $226.28. Okay. Then we got one more line to do. Same idea. Your new principal is 226.28. You do the 0.025 times that principal, and that's going to end up giving you a new interest of $5.66. And at the very end of the problem, you're just doing the 226.28 plus the $5.66. So that will end up giving you $231.94. Okay. So what I want to do is kind of use this table to compare with the table on the previous page when we did simple interest. Okay. Now I was kind of writing down those calculations pretty quickly, but does everybody see what I'm doing on that okay? Okay, I mean, it's the thing that I want you to notice on compound interest is, number one, the principal goes up and the interest goes up. But I also want you to notice this. If you go through and look at this, the interest, it's going to keep going up in a similar amount. So it keeps looking like it's going up about around, it's actually increasing if you look at that. That's like 13 cents. I rounded that. So this is up like 13 cents. Now it goes up about 14, up about 14. It's actually going to increase. And eventually it'll start doing that. It'll start really increasing. Okay. That's the way compound interest works. So it kind of starts off slow. So if we did this, like if we had an Excel spreadsheet and we did this for like 50 years, you'd probably be surprised by how that amount would grow. It would start picking up pace quite a bit. Okay, does anybody have a question about how that works out then? Okay, that's all table is. So if you look at simple interest on page 2, notice on that we got $230. Simple interest, the principal remains the same, the interest remains the same. On this case, we just kept going up $5. Okay. Compound interest works to your advantage. If you're doing a savings or an investment, you're making a little bit more money. So we actually made $1.94 more than we did if it was simple interest. Okay, all right. Any questions? Okay, all right. Okay, very good. Now on page 4, what we'll go ahead and do is we're going to look at. I was going to show you, you can do this on a spreadsheet. I'm not going to do the spreadsheet in class because that's not something that you're going to have to know how to do. But if you've ever used Excel before, you can make a spreadsheet that could create this chart pretty quickly. Okay, so what I want to do on this is we're going to just kind of compare two things. We're going to compare these two investments. We're going to compare the simple with the total compounding. Okay, now what I'm going to do is I'm just taking these two charts. So first of all, let's go ahead and do what we got on the simple interest. Okay, and this is real easy. This just goes up by $5 increments. So go ahead and start filling that out. So that's going to go up to 205. Then it'll go up to 210, and then up to 215, and so forth. Okay, so that's what we did. I think it was page 2 when we did, this was like Nancy, I think. She did an investment by simple interest. Okay, so that went to 225. Eventually, she ended up with $230. Okay, compound interest, I'm just taking the information that we got on the previous table. So the one we just did, we started at 200, then we went to 205, but then it's different. So now it started going like this. I'm just taking again the numbers that you wrote down on the previous page. 210.13, then it was $2.15 and 38, and then $220.76, then 226.28, then 231.94. Okay, so we're just going to kind of look at the difference between these two numbers and how that goes. Okay, so that's are the two charts we did. Now I'm just kind of doing a subtraction. I'm just doing on this, I'm doing 200 minus 200. So there was no difference at the beginning. That was $0. Okay, then if we do 205 minus the 205 there, there's still no difference here. Okay, so there's the thing on this is, oh, I know, this is what I intended to do, was I intended to do this actually. Okay, $0 correct. What I intended to do was the 205 minus the 200. Okay, so that is $5 there. What I'm doing on the difference is I'm looking at the compound interest. So now what I'm going to do is I'm going to do the $210.13 minus the 200, and that's going to give me $10.13. Okay, because what you know is happening here, for Nancy the difference is always $5. It's always going up $5. But what's going to happen on this is that's going to change a little bit because of the interest. Okay, and I'm just going to kind of give you I'm going to write down one more calculation. Now we would go to 215.38 minus 200, and that would give you $15.38. So this is showing how the compound interest is growing over time. Over 3 years later, the compound interest investment has gained $15.38. Okay, if you continue to do the same computations, what you'll have on here is, and I think I kind of got off track with this here. I think I just kind of, I thought I missed one is what I did. I'm sorry, I missed one of these things. So if you go here, this should have been, this one I think was $5. I'm doing this wrong. Okay, this one would be $5.13. So what I'm doing is I'm subtracting the previous month. Okay, I was thinking of something different. What I did to get that amount right there is I did the 210.13 minus the $5. Okay, so I'm kind of looking at what happens between these two numbers right here. Okay, that's what I'm doing. Okay, then I'm going to do these two numbers right here. I'm going to take the 215.38 minus the 5.13, and that's going to give $5.25. I'm just seeing how the interest is growing every month. That's it. Okay, then I'm going to do this number minus that number, 220.76 minus 5.25. That's going to give 538. Then I'll subtract these two numbers to get $5.52. Then I'll do this to get $5.66. So what I was trying to show you on this is you can tell that Nancy's investment kept going up $5, okay? But Samantha's balance kept going up a bigger number over and over. You guys understand what I did there? I just take it like that number minus that number minus that, and so forth. So what's happening is the interest is growing too, and it's growing at an increasing rate. So that's how that basically works out. Okay, so that was just kind of a comparison to put that together. Now, Excel spreadsheet, I'll kind of show you some of that stuff a little bit later, but you can set up Excel spreadsheets that do stuff like this by doing simple calculations. I'm not going to show that today, but we'll get into some spreadsheets. This is basically the same thing that I did, the same table, but the table went out a little bit more. This is if you did this up to 8 years, 594. So in practice, you wouldn't want to tediously do all those rows. You can set up spreadsheets real quickly and bring that down as far as you want to. You could take that easily up into 100 years or 1,000 years or whatever. Okay, so I'm going to show you when we get into mortgages and stuff a little bit about how spreadsheets can be built. Okay, all right, let's go to the next page here. And what I want to look at on here we're going to kind of develop the compound interest formula here. So this is some things that we learned. This was like a question on your test. I was very similar to this. So if you're 5% more, does anybody know what that means? What percent of? There's a real simple calculation to do. 5% more means what of? Anybody know that? There you go, 105. Okay, the computation is 5% more than is, okay, 100 plus 5%, or 105% up. There was a couple of questions on your test that were asking that, okay? So this means that this is 105% of the old balance, okay? So what we're going to do is I'm going to show you how we can get a compound interest formula out of this. I'm going to try to show you where the formula kind of comes from. So now what we would do is at year zero, after the end of a year, you're just going to take the 105%. And again, if you have 105%, you move the decimal to the left 2 to write that as 1.05. Then you're going to multiply that by, let me put a time sign here, that will be times the year zero principal, okay, like that. That's going to be the principal, the beginning principal, like that. So that's how you would calculate the interest after 1 year. That's just taking the principal times 1.05, okay? Now, here's the next thing that happens. You go to year 2, now what you're going to do is you're still going to do 1.05, but you're going to multiply it by the principal you got by doing that calculation. Okay, so what I'm going to put here is I'm going to put 1.05 again times year zero. Okay, because remember what I'm doing is I'm doing interest on interest. And you did this calculation on the table, so I'm doing, okay, that's my new principal. So when I go to the next time period, I take that times the new principal. Now we're going to see a pattern, hopefully you'll see a pattern that exists on this then, okay? So now I go to year 3, I'm doing 105% or 1.5 times the previous thing, and that previous thing would be this entire thing right there. So what you would put there is you would have 1.05 times 1.05 times year zero principal. Okay, so what I'm doing is I'm doing interest on interest essentially here. Okay, all right. So what I'm trying to see is if you see a pattern on this, okay, because there is a pattern. If you look at year zero, how many times did 1.05 show up there in that calculation? 1 time. How many times does it show up there? 2 times. How many here? 3 times. 3. Okay. Okay. So if you multiply a number out 3 times, you can write that as a third power, right? Right? If you write something out twice, you can write that as a second time. Okay. So what you would get is in general, it would go like this. It would be 1.05 to the t power, t just being the number of years, okay? And then it would be times the year zero principal. So when you're doing a compound interest formula, there's going to be an exponent in there. If you went on to year 4, you would just see that 1.05 shows up 4 times and so forth. Does that make sense? It's because you're doing interest on interest. That's why it shows up the way it does. So this here will kind of give us a basic compound interest formula for now for doing interest annually. Okay, it's going to be a little bit different when you start doing your interest more often. Okay, so anyway, the next thing, if we go to the next situation, we're going to go ahead and just do an accumulated value on this. Okay, so with this particular problem, you have $500 is in your account. So we're going to start off at the beginning you're just investing $500. You're putting that in savings or something like that. So what we're going to do is when we go to year 1, it's going to go like this. We're going to do 1.05 to the first power times the $500. Okay, that's what we're going to do. We're just taking, again, we're doing 5% per year. So 5% more than is the same thing as 105% of. Okay, so we have that. Okay, so when we do this calculation, then this right here is going to be, if you take the time, if you do that on your calculator, you're going to get 525. Okay, so this would be like after the first year. Again, you're just taking 1.05 and then you're multiplying that by the 500. Okay, all right, so that'll give you that amount like that. Now, we go to year two, it goes like this. Okay, now what we do is we do 1.05 to the second power times 500. Okay, and again, if you do that on your calculator, you would just put it in like this. You could put in 1.05 raised to the second power and then times 500. And that amount would give you $551.25. Okay, so that's how that goes. So what we're going to do is just kind of the same thing. I'm going to do one more row, and then I want you to just take your calculator and fill in the rest. So the next one you get to third year, you do 1.05 to the third times 500. Again, you can put that on your calculator like this. You just got to raise that to the third power. And then you can multiply that by the 500. You're always multiplying it by the original principal. And then this would round off to about $578.81. Okay. All right. You guys see how I'm doing that? So go ahead and take a couple of minutes to finish up the next three rows, and then see if you can write a general formula for n number of years. Okay, then I'll put the answers up here in just a minute here. Okay, so this is how annual compound interest works as you're going through these basic calculations. Okay? Just make sure you know how to do your exponent and stuff on your calculator. Okay, whatever calculator that you're using. And the amount should just keep going up, and it'll go up at kind of an increasing rate as we go through that. Okay, then we're going to begin to look at just kind of the general compound interest formula today also. So did anybody get all the way to the 10 years and get an amount? Yep. I think, what did you get? 814.45. Yeah, that's what I got. Okay. So the calculation, I'll go ahead and just kind of put what the results are here. You just want to make sure that you have everything set up on there and everything. So here's what you end up having. I'll zoom in on this so you can see this. And it's a nice, simple pattern that shows up. So you can get these written down if you didn't get these. But you just want to make sure you can do that on your calculator. So again, all you're doing when you get right down to the 10th year, you're taking the interest rate to the 10th power times the 500 principal, and that gives that. So you're noticing after 10 years, you've gained quite a bit of money. You've gone from 500 all the way to $814.45. Compound interest, as you get into higher times, it starts getting real big. So let's just do one other thing on here. Let's see what happens if you did like 50 years. Let's just see what would happen on the calculator. Let's see what would happen. So the way you would do this is you would do 1.05 to the 50th power times 500. So put that in your calculator and see what you get. It might surprise you. I don't know. Okay. I mean, these things start kind of spiraling out of control on compound interest. So we're going to do 1.05 to the 50th power. So that's after 50 years. Then we'll multiply that by the $500 original principal. Look at that. That's $5,733.70. So see what happens when you get into real high years. It starts just getting out of control. I mean, you've made over $5,000 in interest after 50 years. That's the way compound interest works. It gets bigger and bigger at an increasing exponentiating rate. Okay. All right. Do we have any questions about that chart? Okay. It's a real simple pattern. The exponent, the number of years, becomes your power that you do in your basic formula. Okay. All right, let's go to the next page. Now, here is a general compound interest formula that I'm going to show you how to use here in the next kind of couple of cases here, okay? Because I want to kind of get started here. So this is a general compound interest formula for when interest is paid once a year. We'll look in a little bit, we'll look at what happens when you do interest more than once a year, okay? So the way that goes is this. P is your starting principal, R is your interest rate, T is the number of years. So it's very simple, similar to what you just did on the previous problem. You're taking the principal times 1 plus the interest. And remember, when we did that last problem, it was 5% more than is the same thing as 100 plus 5, or 150, 105 of. So it's similar. So let's work with this formula here. So example 7 says your grandfather puts $100 under a mattress for 50 years ago. Okay, if he had instead invested it in a bank account paying 3.5% interest compounded yearly, let's find out how much it would be worth today. So go ahead and write down the formula, which is going to be A equals P times 1 plus I to the T power. And then we're going to write down everything we have. Okay, so what's the principal in this problem? $100. Good, that's $100. Okay, what's the interest? 3.5. If you change that to a decimal, what is 3.5 going to become? 0.035, right? You move the decimal to the left too, okay? And the time on this is 50 years, okay? So what we need to do is we just need to set that up in this formula. So replace the P with 100. Then you'll have parentheses, 1 plus the interest. So that's 1.035. And then raise that to the 50th power, okay? So let's see what that is. This is kind of like the problem we just did. You might be a little surprised at how much that $100 would grow to, okay? So when you put this in your calculator, use your parentheses keys and just do it in one step, okay? You don't have to put a time sign if you have a TI like I have. You just put that like that. Then you can do 1 plus 0.035, which you can do in your head if you want to, and then raise that to the 50th power. So that's how that gets put in there. So let's see how much that $100 becomes. Okay, so that becomes $558.49. Okay, so you've added to your investment over $400. Okay, you've made like 400. If you take 558 and subtract 100, you've made $458.49 in interest. Okay, so again, when you get up to big time periods, that's what's going to happen. Okay. All right, do you guys understand how that formula works okay? Everybody good? Okay, all right, okay. The formulas that we're going to learn are they'll get increasingly complicated, particularly when we get into the mortgage formula and that kind of thing. So what I want you all to do is let's go ahead and do the problem 1 at the bottom of the page and the problem 2 on the bottom of the second page, okay? And you guys can work a little bit together on that if you want to. And I'll give you a little time to do that. I'll walk around and see if you need any help. Just using the same formula, And just make sure you can do everything with your calculator okay on these, okay? And if you have any trouble with your calculator, just let me know when I walk around, okay? Now you're going to get, like on that first problem, you'll get an answer in scientific notation. That's what happens on my calculator. So you want to convert that to, just regular notation. I got something times 10 to the 11th when I did the calculation on number one. So 535 years is going to give you a super big number. Now, if you want to round this off, you can, but you'll end up on your calculation something to the 11 times 10 to the 11th power. Okay, so let me just kind of walk around and see if we're having any trouble putting these two problems together. Yeah, you got it set up right. That's good. So you got a calculator to do that. Okay. And I think you'll end up with something like 2.9 or something times 10 to the 11th or something. Yeah. So you just need to move the decimal over to the right 11 places. And I don't want you to write your answer in scientific notation. See what you do now, just move that thing over 11 places to the right. What's that? So the principle on that, it says you borrow an equivalent of 384, you paid back 160, but never paid back the 224. So the 224 is your principal. The 384 and 160 are just saying the original loan was partially paid and you forgot to pay back the rest, okay? Well, that's how that works out. Okay? So your principal is $224. Well, just think of this is the way I do this. I can just start counting. I move it over one place on the 29. Now just start counting. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Every time you get 3, that's your answer. That's what I got. Oh, I see. Okay. Okay. Times 10 to the 11 is a super big number, so the decimal's got to get that one. Okay. Okay. So there's two problems. I want you to work the one on the other page. I just rounded it off. And that's okay. I got like 290. Yeah, yeah, yeah. I just rounded it. That's okay. Because you'll end up having like 290 billion if you round it off. So that's a pretty damn good investment. Yeah, you'd be long dead, but at least your ancestors, your children's children's children would get all that billions of dollars. You do the personal thing. So with this one, it's this is your principal. And what they say is your original loan paid off 160, but you have this one bill. So that's what that is. And then your interest is 4%. You use 4.4, you always use the investment times 535 years, and you're going to use that formula. Principal 3.4, interest 104, 535. Then you want to use your calculator. Did you get something like 290-ish billion-ish or something on the first one? Yeah, that's it. That's what I just rounded it off. So you get the first one like 290 billion. That's all. That one. That's good. You get like on the first one. Yeah, I just did 2 point. It's 2.9 times 10 to the 11. I just rounded it off. Okay, you get what you do on the first one. Okay. Perfect. Okay, now what you want to do is just move the decimal to the right place. Like that, just so you can kind of see what that means. That's okay. What you did there is okay. I went ahead and just wrote it out here. 290 billion, okay? But that's fine, okay? I mean, that's more accurate. You want to get all the money out of this investment you can, so I'll let you know. That's good. So you can, okay? Okay. Yeah, just change that to regular notation. Move the decimal to the right one. In the calculator? So see the interest, you have to move the decimal back too. If you did this on your calculator, the amount of money you would get would be unbelievable. It would be more money than in all of the banks in the world. So it's 1 point that you're going to be 1 plus point. Okay? Yes. Okay, now you do have a 1 plus point over here. Okay. So you can just do on your calculator, you can do 224 times 1.04 to the 535 pounds if you want to. And the reason you get such a big number on that is because 535 is 6 pounds. Okay, here's why. You did what she did. You need to have 0.04. Okay, so that's why it's overflowing because I usually tell them how to. So see if you did it, you don't. Okay, all right. So, yeah, a couple of things on this. You guys are doing mostly fine on this. What happens on this first problem is, you got the formula, you have 4%. Now, the thing that a couple of you weren't paying attention, you have to make sure you use 0.04. If you use 4, I think you were doing that and it overflowed your calculator, right? Okay, so when you put that in, and what I did is, if I put this in my calculator, if I just do 224 and then times, you can put 1.04 in there, and then raise that to the 535 power, it's going to give you this in scientific notation. So I went ahead and just thought of this as rounded. I just thought of it as 2.9 times 10 to the 11th. Then I moved it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So that's $290 billion. So that's what I like this example because it shows you what happens as interest gets out of control. This is $224 has now changed into $290 billion. That's because the 535 is such a big exponent. Okay, that's the idea. Okay, does anybody have a question about how that problem worked then? Okay, all right. So the second problem, I think, did you get something like 44,000-ish or something kind of like that? Okay, all right. So I'll give you what the answer was on the second one here, and then we'll do a couple of more things. I am going to pass your test back and kind of tell you what you need to do over the weekend for some points. Okay, so this problem right here, you've got 20,000 as your principal, 2%. Again, you wanted to make sure that when you did that, you changed that to 0.02. When you do that there to the 40th power, that's how it would be set up. So your answer would be $44,160.79. Okay, so that one is 40 years. So notice on that your investment practically, it doubled, it more than doubled on that. So that's how that works out. Okay, anybody have a question on how that works out? I didn't see too many issues. The only issue I saw was not moving the decimal back, and you have to do that, and you'll catch that mistake, hopefully, because either your calculator will overflow or you'll just get a ridiculous answer, okay? All right, let's go down to this example 8, down kind of at the bottom of the page here. And this is doing the problem sort of in reverse, okay? All right, so everybody got this written down? You can always take a picture too, like on your phone. That's fine. You can always do that if you want to. Does anybody need to take a picture of that? You're still writing over there? Okay, take pictures if you need to. All right, now let me go down to the bottom here on this example 8. And I'll show you kind of how this thing basically gets set up here. So with this problem, what you have is it says that suppose you have a new baby and you want to make sure that you will have $100,000 for his or her college education in 18 years. How much should you deposit at an interest rate of 5% compounded annually? Okay. So we're doing this problem kind of backwards. So go ahead and write down your formula. This is what we've been working with is A equals P times 1 plus I to the T power. Okay. So now in this particular problem, the amount is 100,000. That's what your savings goal is. What you want to find is you want to find the principal. You're trying to find what you're going to deposit into this investment so eventually you have $100,000 for college. Okay. Your interest is 5%. And again, when you do 5%, make sure that you change that back to the 0.05 like that. The time is 18. Okay. Now, let me show you what you're going to do now. We're going to go ahead and set up the formula. We have to do a little algebra. It's pretty basic algebra, though. It doesn't have too much involved in it. So it'll go like this. When you put into your formula, you're going to put the 100,000 in for A. So that will be 100,000 in there. You're going to leave the principal as P because you're trying to find P. Then you'll have 1 plus the interest, 0.05, to the 18th power. Okay, so you got to know how to get everything set up. Now, there's a couple of things. We haven't done a lot of algebra in this class, but suppose you had this equation instead. What if you have the equation 10 is equal to 5 times P? What do you do to both sides of that equation to get P by itself? You divide by 5. Okay, you divide by 5. Okay, that's kind of a basic algebraic equation. You do that. Okay, so if you had anything, like if you had 10x equals 120, the way you solve that equation is you divide both sides by 10. That way you end up with 1x, and that's what you're trying to find. So that would be x equals 12 in that case. So what you do in this problem to solve it is you divide by the number that p is being multiplied by. So this is just doing algebra. It's only a one-step algebra. As we get further and further into the finance, we're going to do a little bit more algebra, but I wanted to review why I'm doing what I'm doing. Okay, the reason that works is because that divided by itself is 1, so you just end up with P is equal to 100,000 divided by 1 plus 0.05 to the 18th power. That's what you got to put into your calculator then, okay? So if you want to take your calculator out, then you just are going to put this in like this. So you want to take the 100,000 and you want to divide that by, just put it exactly like I have, 1 plus 0.05 raised to the 18th power, okay, like that. Okay, so put that in. That will give you what the principal is. So that principal is working out to be about $41,552. $41,552. I rounded that off. So what this would mean is if you had $41,000 to invest into some sort of an annuity or something like that that did interest this way, in 18 years, that 41,000 would grow into 100,000. Now, annuities don't work that way. We are going to learn an annuity formula in this class. It shows you how real annuity investments work. Compound interest is not typically used on these type of amounts. But this would be what you deposit. Eventually, the interest would accrue and grow to the 100,000 like that. Does that make sense? What I did? Okay. That problem, we're given the amount and we're trying to find the principal. Okay. Okay. So now everybody picked up these two handouts. One of those handouts is the exam wrapper. I'm going to shut off this recording here.